Good morning or afternoon or indeed evening. Thanks very much for attending this webinar looking at the structural tools that have recently been added to GEOVIA Surpac. My name's Chris Bates. I'm a geologist within the services team for GEOVIA based in the UK. My own experience ranges from exploration to production and from industrial minerals to precious metals, both in the open pit and underground mining operations. Today's session will introduce the functionality that now exists in GEOVIA Surpac for the import, the management, interpretation and visualization of structural data. As we're already aware, the importance of an accurate geological model can't be overstated from a resource calculation point of view. And without one, we wouldn't have any idea of how much of the stuff we're interested in we have, where it is and how best to get it out of the ground. So to this, we can now add the ability to utilize the structural data that we often obtain easily whilst drilling or during the exploration phase through surface sampling and mapping, or indeed during production, and that never normally makes its way into software packages such as Surpac. This information can be used to build a geotechnical model, and it's here that improvements can be made to mine safety and therefore the bottom line. Detailed knowledge of the structures at play in our deposit mean a greater confidence for mine design, and this in turn can lead to a better management of any geotechnical hazards in the deposit and a reduction of risk for those working in these areas. This greater certainty reduces mining cost by helping to ensure that mining is right first time. Today I'm going to show you some of the key features of this new suite of functionality that is now available with GEOVIA Surpac. We'll see how user-friendly the functionality is, how each function can be used independently, and how the results are clearly displayed and simple to understand. As has already been mentioned, please do keep any questions verbally until the end of the session, or you can ask by typing them into the chat bar. And if you'd prefer to ask questions by email, I'm more than happy to receive them at chris.bates@3ds.com, and we'll ensure that any questions are answered as soon as possible. So with my introduction out of the way, we'll move on to the demonstration of the structural geology functions within Surpac, and of course we'll have that question and answer session at the end. Firstly, let's have a look at where all of the structural suite functions are located. You'll find these within the database menu with their own submenu at the bottom of the list. Any function that we want to use within the suite can be found here. So let's have a look at the database that we'll be using and see an example of some of the data that we'll be storing down the holes that we'll be using throughout this webinar. I'm going to color the drill holes to show the domains that we're using. I'm going to have a fixed width so that we can display them more easily on the screen. And I'm going to display some of the geotechnical information that we have down each hole. In this instance, I'm just going to use the dip. I'm using a bigger offset to compensate for the fact that I'm using the wide cylinders. I'm not going to constrain the holes at all. I want to see all of the holes. So as you can see here, these domains are quite clearly defined, giving us a simple data set to work with for the purposes of this webinar. And as I look down the hole, I can see all of these measurements. The idea of this suite of functions is that we're able to utilize this information and visualize it better to help us with our day-to-day working from a geotechnical point of view. In order to use all of these functions effectively, we need to make sure that our data is stored in the database in the correct way. And there are two main table types that we use for doing this. The first of these is our discrete table, and I'm going to look at an example of what that will look like right now. So we go to the Edit View Table function and we pick our Surface Geotech table. This is the table that stores individual pieces of information that aren't related to a drill hole. So you can see in this example, the column title here is Sample ID. This might be information that is recorded during a mapping project, or indeed information that's taken as part of production management underground. And you can see that each of these has its own individual YXZ, and in this instance we're storing dip, dip direction and strike in the table. So the other table type that we're going to have a look at is what we call a point table, and in this instance this is our geotech table. In this instance, the data is related to a drill hole, so you can see in common with a normal interval table, the hole ID is the first column that we have, and as Surpac normally does, the Y, X and Z have been calculated based on the depth to and other information stored about the hole. In this table as well, we're storing dip direction, dip and strike, and we can use those within the functions as we work through this webinar. Many of the functions we'll use start by selecting the Data Visualiser from the Structural Suite menu. So we'll start by taking a look at the surface geotechnical information that we have and how that's displayed in graphics to allow us to begin our interpretation. So to begin with, I select the function and start to work through each part of this form. So the first page allows me to specify the information that I want to display and to start thinking about how I wish it to be displayed. So the table to be selected here is the Surface Geotech table, and you can see that all tables are available for selection. And I then get to specify which fields we're going to use for dip and strike, or dip and direction, whichever way you want to specify these. And then we move on to the next part of the form. This part of the form allows us to enter any constraints that we wish to use. With such a small data set, I'm not going to be using any constraints in here today. And then we can move on and specify our symbol styles. There are many symbol styles that can be used for the display of this information, and as you'll see in a moment, these are actually created as new files within Surpac for later use. So the drop-down list is populated with all of the standard symbols that are part of the function suite, and in this instance we're going to select the octagon. If you wish, you are able to create your own symbols and they can be used and added to this drop-down list. The standard GEOVIA training for this product will actually deal with how to do that. Now, I am able to scale the symbols by a field, so I can have a bigger octagon if I have a larger value for the dip, for instance, but on this occasion I don't want to do that. And I already know from past experience that 30 is a suitable number here to use for the symbol scale. The last part of the form allows us to colour the information that's being displayed. So this is obviously the easiest way for us to be able to make a quick interpretation of the data and a quick evaluation of what it's showing. So we can choose the field to colour by, and in this instance I'm going to select dip. You can see I can colour by other data if I wish to, and I'm able to choose from a list of different colouring types. As you can see, these change very easily and are customized at will should you wish to do so. In this instance, I'm going to use the rainbow, and once complete, we simply press apply and the geotechnical information will be displayed. The amount of time taken to display the information, of course, does depend on the size of the data set that's being used. So as we rotate this data, you can see that the red discs are those where the dip values are greatest, and you can see that the blue discs are those where the dip value is lowest. And of course, for context, if it's an area particularly you're familiar with, you can display any local topography and see how those data points coexist with the topography. Downhole information is displayed in much the same way, and although not necessary, I'm going to start by simply displaying the drill holes to remind us of their location. And again, I then select the Data Visualiser to allow us to make all of our specifications for the display of the downhole information. So in this instance, I'm going to select my geotech table, which we looked at earlier on, and we already know is a point table containing the information recorded downhole as part of the drilling process. And this time we'll select dip and dip direction using the dip field and the dip direction field. Again, we're not going to use any constraints, and for the symbol styles, we'll use the same symbols as we did beforehand. Just for a little bit of a difference from last time, we'll use hot to cold for our colouring style. And again, simply press apply for that information to be displayed on screen. So you can see here now that all of the geotechnical information that we have recorded downhole is available for us to look at. With this being quite a large data set due to the number of points, it does take a little while to display properly, and you can now see each of those disks is displayed as we wished. As I mentioned previously, and worth noting, is that the points and the symbols have been created as new layers within Surpac, and these can be saved from the layers pane down at the bottom left of the screen. The next function to look at is to create a stereo-net or a stereographic projection from selected data. In this instance, we're going to use some of the surface geotechnical data, so we'll go back through the process of displaying this information. And as you can see here, the information is displayed, and I'm able to select some or all of the data to create my stereo net. To do this, I simply go to the Structural Suite, Create Stereographic Projection, and I digitize around the area that I'm interested in. So I'll just utilize this area here. This doesn't need to be closed completely, as in a closed string, and once I've completed this selection, I simply press Escape, and my stereo net or stereographic projection is created in the next viewport. If I wish to, I can then come back in and make another selection. So in this instance, I'm going to select all of the data and simply press Escape to utilize the function, and the new stereo net will be created. Once I'm finished with this, I can of course just simply close the viewport and carry on doing the rest of my work. The stereo net is a useful visualization of what the data is telling us for a large number of samples. But sometimes we want to be able to summarize the information or to only see one representative point for a group of samples. So what I'm going to do here is to display the surface geotechnical information that we were looking at before in the same way. And once I've done so, I'm going to again go through the process of creating the stereograph. So again, I'm going to select all of the data. And once I have the stereo net here, what you'll be able to see is that I do actually have more than one distinct area of interest. What I'm actually going to do now is to select groups of points and to create a mean plane to represent those. And I do that by selecting the function down here, which is to create planes from stereographic projection. Firstly, I'm going to create one using this set of data here, and that's been created within the bounding box and within the group of samples to which it belongs. And then secondly, I'm going to use the function again for a second time, and I'm going to create a plane to represent this data here. And that's now being complete. So I'm finished with my stereo net now. So at this point, I will close this viewport. And back in this viewport, I'm going to go ahead and make all of my points and symbols from before invisible. Of course, you can go ahead and delete the layer if you don't want to keep the layer. And you can see now that we have these two disks that represent those groups of samples before with mean values. Now, at the moment, they're quite small. It's difficult for me to judge the relationship with each other. So I do have the ability within here to very easily change the size of the segments. It's just a quick click and drag operation, which makes those segments much bigger. And now I can see how they interact with each other if I wish to do so. And I do have the ability, lastly, to be able to get more information from those. So I can go back into my function chooser, and this time I'm going to choose the dip and dip direction from 3 points. And if I take any 3 points on the edge of the circle, I'll get my dip and dip direction reading down there. And of course I can do the same thing for the other circle, and I've got that information then to keep. Additionally, one thing that I can do if I wish to save this information, which is very straightforward, simply make this, simply save this layer. then I have the information available to me to use as a very simple string file, which I can then choose to format additionally however I would like to later on. And if I want to, then I do have the ability to go in here and actually make changes to the data by adding in some extra description fields. You'll notice that the azimuth and dip information is actually automatically stored with the symbol as well. As well as being able to create structural symbols from information that's stored in the database, we can also manually construct symbols. In this instance, we're going to use this .obj file, and because we have a lot of bedding planes within this file that could represent points of weakness, we can select 3 points to actually create a symbol that will delineate that information so that we can see it more clearly. So if we zoom into an area of interest within the file, we can select 3 points along this bedding plane and use the functions within the software to manually create that symbol. Dependent on the size of the OBJ file, it can take some time for this function to work. And of course, you do need to be quite precise. I'm doing this very quickly, so the result that I get may not be perfect, but it will give you an idea of how the functionality actually works. Once I've completed selecting all of my points, simply press Escape and Apply on the form, and the symbol is created. I can now rotate around in graphics and see how that symbol actually sits in relation to the rest of the information that I have displayed on the screen. In addition to this function, there are other functions that we can look at to analyze and review areas of weakness within a surveyed pit wall such as this. And indeed, in this instance, we can see here what looks to be an area of faulting. And of course, this does intersect some of the bedding planes that we were already looking at. So we are going to use the fit plane to points function within the structural suite, fit plane to selected points. And this will allow us to review and analyze these areas. So once we've selected the function, we wait for the command prompt to come at the bottom of the screen to instruct us to select a point. Again, dependent on the size of the point cloud, this can take a little while. And once we've done so, we can select points, and as you can see, this plane is updated dynamically as we're selecting points across this bedding plane. And once we've completed the selection of the points for the plane, we can press Escape, and we have the option then to start to digitize a new plane should we wish to do so. And of course, I'm going to do that using this faulting surface here. Once I've completed, I can escape out of that function. I can actually hide the pit wall if I wish to do so, and I can now review this plane data. Of course, as we have already seen within the function suite, we do have the ability to create a stereographic projection from any of the orientated data that we have within our graphics window. So I'm going to go ahead and select all of that data. And as you can see, I now have a StereoNet or stereographic projection, which as a geologist or indeed as an engineer, we can use to make safety decisions for the further development or safety management of this particular area of the mine. It is also possible to obtain quick pieces of information for areas of concern that we might have where it's important to get an understanding of the situation very quickly. As you can see here, I can identify that there does appear to be another faulting surface here in the wall, which again could represent an area of weakness. And what I'd like to be able to do is to very quickly get a handle on what's going on here. To do so, I can come back into the function chooser and I can select dip and dip direction from 3 points. And what this does is allows me to select points on the surface that I'm interested in, and then down here in the message window within Surpac, I can read off the dip and the dip direction very, very quickly, and that allows me to make a comparison between any of the other known information that I have within the pit, and isolate areas for any further investigation that I wish to do. So in addition to using the information stored in the database or in point cloud or other surface file, it can be useful to interpret information that we have stored in a string file or similar. So this string file that I have here shows a couple of major faults in red and a lot of crisscrossing minor faults throughout the area that we've been looking at. So what I'm going to do now is look at a function that allows me to take a segment and to produce a plane to best fit that segment. So as you can see, when I click on this segment, then a plane is produced that allows me to visualize what that fault is going to look like in terms of the plane. I can do this for as many of the minor or major faults that I like, but what I'm interested in is another one nearby that intersects and looking at the relationship between those two faults. As with before, more information has been created and put into a new layer, so I'm able to save that for future use if I wish. I can, of course, edit these planes and make them bigger if I wish to do so, as you've already seen. But from a safety and mining point of view, what we're actually interested in is the intersection between these planes. And we do have a function that allows me to look at this line of intersection and, of course, to keep it for future use. So within the data chooser, the function chooser, again, I can go down to the intersection of two planes. I simply select them, 1 and 2. The order isn't important. And the line of intersection is created. So if I hide the other information that I'm not interested in and I get rid of my temporary markers, then you're able to see the information here displayed as a line, and you're able to see some of the parameters of that line that we're actually interested in within the message window. As well as being able to fit a plane to a string or a segment, we also have the ability to fit a plane to a DTM, whether that's a surface or a solid. So in this instance, I'm going to use the ore body solid from the standard GEOVIA demonstration set and just simply go into the structural suite function chooser and choose the function to fit a plane to a selected DTM or solid. This function then works on whichever trisolation you click on within the active layer, and as you can see, the plane has been generated in the same way as elsewhere within the suite of functions. And again, new data has been created. It's made the active layer within the layers pane, so you're free to save that and use it later on if you wish. So the next function that we're going to look at is more complex than the other functions that we've been looking at, but is very useful for visualizing data over a large area. What we're actually able to do here is to take a DTM or SDM surface and to be able to take the dip and dip direction measurements from the triangles contained within that surface, to extract those, to put them into a database so that we can then visualize them later. So the topography that I'm going to use is the one that comes with this data set. And when we launch the function, obviously the first thing that we're going to do is to actually select the DTM that we want to take the gradient information from. So make sure that's in the active layer. First thing that we have to specify is what is called our cell edge length. This is the edge of each square that will be generated by Surpac. And Surpac generates these squares to select a group of triangles, and the triangles within each of these squares are then averaged out for dip and dip direction, and one measurement is then put into the CSV file for each square within the surface. So 100 meters is fine here. The measurement that you'll use on your own data would obviously depend on the size of the DTM and the number of triangles that are contained within it. So I'm outputting to CSV file. I have the name here. I want to include the column headers just for my own information and to make it easier for me to establish which is which. And once I click apply, Surpac will go off and do the work. And once complete, the CSV file will be stored automatically into the working directory. I've chosen CSV rather than string because I wish to be able to import directly into the database as soon as possible. So you can see the CSV has been created here, and we can drag and drop that into Surpac and take a quick look. What you'll notice is I have sample ID, I have my coordinate data, and then I have dip and dip direction information. And this is exactly the same format as the surface geotech information that we had and we were using earlier on in the webinar. And that means that it can be stored in the database in the same way. So what we do need to do if we want to use this in the database is to already have created a table, a discrete table, the same as for the surface geotechnical information. And I obviously did that earlier. And once you've got that table in place, you can then go ahead and make the import. And the import is just using the standard database import data functions from within Surpac. And once you've done that, you can check by viewing the table whether the information has been input correctly. So you can see here, the same as the surface geotech information from earlier on, I've got my table imported into the database, and that means that this information is now available for me within Structural Suite. So again, I'm going to use the data visualizer. I'm going to select the table, which in this instance is my new DTM gradient table. I know that I have dip and dip direction stored within that table. I don't want to constrain, I want to see all of my information. But the symbol styles this time, I'm going to use a different symbol style. In this instance, I'm going to use an arrow. This has been configured automatically so that the arrow will point in the direction that represents dip direction. And a symbol scale of 45 I find is suitable for using with this particular data set. Again, the number that you use will depend largely on the data that you have that you're working with. For colouring styles, I'm going to keep it exactly the same as it was before, and I'm just going to go ahead and display all that information. So as previously, the information is displayed as points and symbols, and with a bounding box. I don't want to see the bounding box or the points, I'm just interested in the symbols. And if I want to, of course, I can make my surface a little more transparent to enable me to see those symbols in greater detail. And of course, if I want to, I can also go ahead and just make a change to the way that this is displayed in order to produce a nicer image. So you can see here quite nicely these areas where there isn't much dip at all, and the areas on the side of the hill where the dip is at its steepest. The very last function that I want to look at today is purely an ease of use function. So if we display our drill holes in the normal way, I'm going to colour them by domain again using a fixed width cylinder, and I'm going to put the hole ID at the top of each hole, and we'll go ahead and put a label in as well, showing some information down the hole. So we're all familiar with how easy it is to display all of our holes, to be able to zoom in and have a look at information that we're interested in, and of course to be able to zoom in and see what each hole is with the names displayed at the top of the screen. But often it can be the case, if you're not familiar with the deposit or with the drilling plan, that someone asks you a question about a particular hole, and it does take a little while to be able to zoom in and identify all of the holes and find the hole that you're actually interested in. With that in mind, the last function that we have to look at today allows me to locate an individual drill hole. So the software reads all of the hole IDs from the database, presents them to me in a chooser, and I can simply pick the hole that I'm interested in. It's immediately highlighted and turned into the center of rotation, and I can see where that hole is in relation to all of the other drill holes in the deposit. Pretty confident, I speak for everyone in my office when I say this is a much appreciated little bit of functionality. Thank you very much for attending this session today. I hope you found it useful and informative. Of course, there is more functionality to discover within the suite, and we hope to be able to do that with you on a personal basis in the near future. We'll have a question and answer session now. We've had a couple of questions come through already, which we'll get to in just a moment. If you have any others, please do type them into the chat bar. And of course, if you wish to have a question dealt with in more depth, more detail, or on a personal basis, you can email me at chris.bates@3ds.com.
first question that I've had is asking if it's going to be possible to use Structural Suite to identify trends in structures in multiple rock types at the same time. And that is something that I didn't cover when we were looking at the data visualizer, but it is quite simple and straightforward to do depending on the makeup of your database. If you store rock type information in the same table as the other information that you're already looking at, so for instance the dip, then it is possible to use that as one of the constraints within the constraint section of the data visualizer, and to therefore only show structural information from within those particular rock types. So you can make a direct comparison between two or more rock types and ignore the data that is actually being shown in other rock types that you're not interested in at that time. I have had another question asking how StereoNets can help anybody to make a decision on mine design. Now, whilst not a geotechnical engineer myself, I can give a basic answer on this. The idea here is that you can use the mean plane function to work out what is happening in general with that particular part of your deposit that you're interested in. You then have that 3D information which you can use to inform things such as your ramp design, your bench angle, your overall slope angle, so that you can avoid that particular plane of weakness and help to improve the kind of safety modeling that's there within your pit.